So I will talk about A/B testing, and the purpose is to present the topic, to share with you some highlights that you may be familiar with some of them, and I guess some of them will be interesting and new for you. Best practice for how to conduct a test, what can go wrong when you run an A/B test, how can it fail, and what can we do to fix it. So that's the main topics. I will share some examples, and also feel free to ask questions whenever you have them. And let's start. Okay. So I will start with a clear definition of the terms that I'm going to use here. So the A/B testing is a way when we want to compare several alternatives, 2 or more. I will focus on 2, but it doesn't matter. We can use more than 2, same issues, same failures that we can have. So we want to compare a few alternatives, and when we compare the alternatives, we want to measure the performance. Sometimes the performance is more than a scalar. You may have several performance indicators, but usually there is one leading indicator. I will address this issue as well. And when you are running such a test, it's very important to define what is the population, or who are the people or the object that we are testing the alternatives. It doesn't have to be the entire population that we have. It may be a subset of a population. And in my presentation, I will focus on applications that are internet applications when you are doing it based on visitors or based on visits, and what are the issues that you may face here. You may face in this domain, but in other domains, there are similar issues in most of the aspects that I'm going to cover. OK. So performance, we have a list of several measurables. In the internet domain, you may look at click-through rate, you may look at bounce rate, you may look at conversion rate, you may look at some continuous measure like revenue per visitor or average order value or whatsoever. So you may have several indicators that you want to measure. Usually, you're focusing on one of them, which is the most important. You can do it on multiple indicators, but let's leave this for a separate discussion. OK. How can we compare? So let's give an example. I want to compare 2 layouts of a certain web page. I want to see which one of them is doing better. I can do it basically in 2 different ways. One of them is serving this layout for the visitors. Some of them will have, let's say, white and blue layout. Some of them will get the white, some of them will get the blue. I will not do it randomly. I may do it near randomly or with several conditions. And then we may look at the overall results, look at all the visitors that we have, and try to build a formula or analyze the marginal effect of this layout. So you try to describe the performance in terms of all the other attributes, regardless of the layout, and then look at the incremental value of the layout. You can do it this way. The issues with doing it this way is that describing the effects of all the other factors is usually difficult. It's not deterministic. I mean, there's not one way to do it. You can have different results, and let's say for most business application, the business user will not really understand this solution. So if you try to explain this to someone who owns the website or manages the website, usually the discussion will end up here, and you will not be able to do it. And that is why we have the other way to do it, which is the A/B test. The A/B test is a way that you compare. I'm having these 2 layouts. I'm going to randomly allocate one layout or the other layout to visitors. And the word randomly is very important here. And I want to have this to be the sole difference between these two populations. So I'm going to split the population into two groups. One of them will see the white layout. The other one will see the blue layout. And I want to keep all the other factors the same in the two populations. That this will be the only difference. Okay? If I'm doing it this way, and this is the only difference, then I can conduct that the difference in performance is a result of the layout and not of something else. So this is the basic concept. Okay? Now, there are a lot of issues how to really do this concept and how to really measure. It sounds simple. It's not that simple. And the word all the rest is equal, the word that I use here, are extremely important. Okay. Okay, so I told you the example. I have two layouts. I call them A and B, or blue and white. My population are the website visitors. Now, whether it's visitor or visits, that's an issue. It sounds simple, but that's an issue. I want to discuss this issue. The performance indicator that I'm going to address is the conversion rate. I have two different layouts, as I said. Objective, I want to find which is the better layout for me and keep this layout because I want to make my business better. Okay, sounds very simple, very straightforward. Well, it's not that simple. Okay. What are the criteria that okay. What are the criteria that we want to achieve? When I say that all, what does it mean, all the rest being equal? All the rest being equal, it means that if you select an item in the population, whether it's the population is visit or visitors, visits mean one session, visitors means a human with all the visits that he's going to place during the test period. And this is different, and I will talk about this difference. But when I say fairness, the first term here, fairness, it means that, let's say we decided to split 30% to version A and 70% to version B. Well, it doesn't have to be 50-50, and I'm going to talk about how the split affects the test, or what are the right split, etc. But for the moment, let's assume that we want to have 30% for A and 70% for B. Fairness means that if I select a certain visitor randomly, the probability that he will be included in group A is 30% and 70% to be included in population B, regardless of any attributes that this visitor have. Okay, regardless of any attributes that he has, regardless any attributes or any allocation of the previous visitor that I had on the site, and independently also with the allocation that is going to be on the next visitor on the site. So when I look at the certain visitor, he must be have the probabilities of 30-70 to be allocated to the groups, regardless of any properties that this visitor have. Okay, that's very important. Then, and we cannot treat the visitors differently whether they got A or B. In other words, any other logic that you have on your website or any other business decision that you have on this website cannot take into account the fact that A was presented or B was presented. But if you want to make the best structure or best test setting, you should hide this information of who got A, who received A, and who received B, and this will give you this property that no one can use this information to allocate. I just jump for a moment. Yes?
Does it mean that a member can, on a specific session, can be allocated with template A, and in another session it can get layout B?
You remember that I talked about visit or visitor? That's exactly the issue. If your population is visitors, it means that you allocated him to A or B, and that's it. For all the visits that he's going to conduct, this is going to be the conclusion. And if the population is visits, not visitor, then yes, you can reallocate every visit.
Multiple times.
Yes, multiple times. And there are differences between these two settings, difference in result, difference in the KPIs that you are interested in. I'm going to talk about it. Okay? So let's just jump for another domain, for medical domain. When you want to test a new medicine, the standard testing says that you have a certain, let's say you have a certain pill that you want to test. So we construct a placebo pill, same pill, but with any material, no really working material inside, and you allocate them to the participants, and then you measure the results. Why are we doing this? Because we don't want the participant to be able to know what did they get, because they may have psychological effect, whether I get the drug or I get the placebo, and you want to measure and you want to assume that everything, all the rest is equal. So if I'm allocating it randomly and the participant cannot see what did he get, then I can conclude that the results are valid. Sometimes you want to test a certain procedure and you want to involve doctors in this. So when you want to involve doctors and they run the procedure, in the medical domain, there is what is called double blind. It means that the person that allocates the patient to the control or the test group, or A or B, is not the person that is going to conduct the operation or the procedure. So you're splitting this apart. Well, eventually the doctor do know whether he's going to do the real procedure or some placebo procedure, and that's an issue. You may have a fault during this decision, but that is how it's handled in the medical domain. Okay, so, and finally, we are using here statistical measures. Well, I don't know if you recall statistics when you learned. I guess most of you did study statistics. All standard statistics, when you compare two samples and you want to measure which one is better and you run statistical procedures, you have standard definition or standard assumption that all the participants are belong to the same distribution in the performance. In this case, we said the conversion. So the distribution, whether the probability to convert or not convert, you assume it's the same for all the participants that were subjected to A or B, and that they are independent. Okay, it's called, typically it is marked as IID, independent, identity independent distribution. Okay, so this is standard definition in statistics or standard assumption. Now, if I'm running these tests on visits, not visitors, then I have a problem with this assumption, because the visitors can be subject sometimes to A and then to B. So they are not really independent. And if I'm running it on even if I'm doing it on visitors, not on visits, then you still have an issue, because in the internet domain, the traffic always changes. Every website that you approach has different traffic, because the marketing campaigns that they are running are different. The intent of the visitors is different. The competition is doing something that affects the traffic. So you cannot really assume that it is identically distributed. So what do we do with this? Well, the simple answer is nothing. There's no real solution for this problem, but you need to be aware that we are violating this assumption we cannot really keep this assumption, but we will try to minimize the effect of violation of this assumption, but we are really violating it. Okay. So here are several settings that are possible to run this test. We want to measure a conversion rate of the visit. The population here are visitors. A visitor. In this case, when you're measuring visitors, it's not really conversion rate, or it is a rate, but it's a rate that can be more than one, because you measure the number of conversions that the visitor had during this test period. He can visit several times, and he can convert several times. So it's not really a rate of between 0 to 1. It can be more than 1, and that's OK. And the independency is violated. If you're using visitor, the first one is visit, not visitor. Should be here population, first row visit. Second one is visitor, and then you're measuring lifetime, not really a lifetime, but the test duration and the indication or the key performance indicator that you measure is the conversion per visitor. And if you when you use the visit term, you may have an issue when the visitor is exposed both to A and B in different visits, and then someone can argue that the conversion that happened during a visit that it was exposed to B was because he was exposed to A before or after. I mean, this is not a clear-cut conclusion that this is the difference. This is the reason for the difference. Yes.
De facto, I don't really understand the difference between first line and third line. I mean, the URI I understand, but de facto, like, practically it's the same.
Okay. Okay, I'll explain. In the first line, we are allocating A or B on the visitor level. So in the first time, randomness, yes, but the first time that the visitor enters the site, I'm allocating, are you a group A or group B? When he comes second time, I don't allocate again. I use the previous allocation. That's the first row, okay?
But then this is row number 2, right?
No, in row number 2, the allocation is the same. I'm allocating on the first visit only, but I'm not measuring the visits differently. Let's take an example, okay? Let's say I had a visitor who visited my site 3 times, okay? In the first line, I'm looking at 3 observations. I had 3 observations. All of them were either A or B, depend on what did I allocate. And some of them had conversion, some of them did not. In the second one, okay, I have 1 observation because I had only one visitor. The fact that he visited 3 times is irrelevant. I have 1 visitor, I may have 0 conversion, 1 conversion, 2 conversion, or 3 conversion, but I have only 1 visitor when I do the calculation and the size of the 2 groups. Okay, this is the difference between these 2 lines.
So in the first line, if there is 1 visit, it is counted as 1. If there are 2 visits, it's counted as 2. And in the second line, if there is 1 or more, it's counted as 1?
Yes, exactly. Okay?
So what's
And
the difference between the first and the third?
okay. In this third visit conversion, right?
The allocation is per visit.
Yeah, you reallocate on the visit level.
אתה יכול להגיד בעברית?
בשלישי אתה יכול להקצות בכל ויזיט מחדש, את אותו ויזיטור. בסדר? Okay, that's a bit tricky issue, but what are the consequences of these decisions? When you're running the first setting, okay? When you are running the first setting, it means that if, let's say, I have a certain alternative, that the result of the alternative that it triggers the visitor to visit again and then convert, you may see negative results because the visitor did convert, but using more than one visit, so the conversion rate may go down. And this is not what we want to measure. We want to measure how do we affect the performance, which is the number of conversions. So the fact that this type or this layout generates more visits per visitor is a positive issue. It does not need to be counted as a negative, which is how it affects the first settings. Rather than the third setting, the second setting, the problem in the second setting is that you're running here on a lifetime, in fact, for the entire test period. So what happened if I want to have a new alternative competing? I want to test something new. This second setting means that you need to start everything from scratch. You cannot use previous data because you don't have the same length of time or same period of time when you want to compare alternatives. So that's a problem in the second setting, but definitely this is, from business perspective or from accurate perspective, this is better settings than the first one. Okay?
Anyway, in the first one I also have to measure again because it may be different visitors with different attributes. By the time I introduce a new alternative, the population has changed.
Yes, if you assume that the population has changed, you're right. Yes. But anyway, the first one has other problems. So, okay, I want to apologize. I will run a bit faster on this issue because this is not really the main issue that I want to cover. I just want to show you a few problems that may exist in A/B testing, and this is one of them. And we can talk a lot only about this issue only. So let's move on. So what are the errors that can happen when we are running an A/B test? So usually, as I said, in the setting that I presented, I want to test two alternatives, A and B, and find out which one is the better. So there is a truth which one is better. I don't know the truth. Well, usually I will never know the truth. I can run a test and make my call based on the test, but I will not have an idea whether I made it right or not. But eventually, at the end of the test, either you make a correct decision when you picked A or B, or false positive or false negative. What is false positive? False positive is when you, by mistake, call the competing alternative a winner. Okay, why are we calling it this way? Because usually in a standard way of running a test, the two alternatives are not equal. You assume that one of them is the default alternative or the control alternative, and you are testing a challenging alternative against it. So false positive is calling the challenging alternative winner by mistake. And false negative is calling the control alternative winner by mistake. Okay? When do we decide to end the test? Okay, we are running the test, we are measuring the performance, the statistic performance, etc. When do we run it? So you can have two ways to set it. One is I'm running it for a certain period of time or certain number of impressions, and then I'm ending the test and looking at the results. The other way is saying I'm going to run it until I have a certain statistical validity. Statistical validity means that this is the probability, in fact, that you are willing to have a false positive conclusion in case that the alternatives are equal. So if I'm running, let's say the control and the challenging alternative are in fact equal, and you are assuming a certain, then the first type of the false negative error is the probability that I will make the challenging one the winner, although it's not really the winner. Okay? So usually or typically in the industry, in the academic, the value of this error or the standard number that are used are 5% or 1% or something in this range. Sometimes people are using less than it. I'm not going to talk about the statistical issues here, about how do you measure the statistical validity, and it's part of hypothesis testing, basic statistical stuff. If there is something that is relevant for this presentation, I will mention it, but that's not, again, the focus here. Okay. Well, that's this one. Okay. Okay, let's see an example, but I don't want to use this one. Sorry, here. This is the one I want to use. Okay. So let's say I've made a test. I had two alternatives, A and B. CR stands for conversion rate, okay? I made my test. I ran it for a while. I calculate statistical significance along the time. And I stop whenever the statistical significance is achieved. It's the p-value is the statistical significance. The lower is it means that the results are more significant. Okay? I think that's good enough for the purpose of this presentation. So I ran my test, and I have A. Conversion rate of A was 9.21. Conversion rate of B was 11.93. These were the results. And they are statistically significant. So it means that statistically significant, B is better than A. So the next question is, by what margin? What is the margin that B is better than A? So if you calculate, you take 11.93 minus the 9.21, you get 2.72%. Okay? Is this the expected margin of B compared to A?
No.
What?
You have a margin of error to take into account.
Again?
You have a margin of error to take into account.
Yes, there is a margin of error. Okay. 2.72 plus minus something. Is this correct?
No, because it's significance.
It's significant, okay.
No, I mean, but the significance has some ranges, so probably much less than this.
better conversion.
Plus minus something. Never mind what is this something. It's something that is smaller than 2.72, otherwise it will not be significant, okay? If the confidence interval includes the zero number, it means that it's not significant. So it's 2.72 plus minus something. Is this a fair estimation of the difference?
I think it's divided by other. It's about 20% better. This was 9%. This is 12%.
Yeah, you're talking about lift. That's a different measure. I'm talking just the incremental conversion rate or the delta in conversion rate. Would this be your estimation for the number?
Well, it would have been if the groups were same size, but I'm not sure when the groups are not.
Let me tell you what I'm meaning, okay? After I have these results, I'm going to test again B versus A, okay? I'm going to test again for a certain period of time. I'm asking you to estimate what is going to be the difference between B and A in terms of conversion. Would you estimate, and you cannot be accurate, but let's say you are measured by a root mean square error, or you are going to be measured in the difference that is going to be there minus the difference that you called in the power of 2. So what would be your call for the difference?
It probably depends on the noise in the data, the variance inside each group. So you can't really know.
The
It
same
depends
variance.
how many observations are.
Enough to have statistical significance, 1,000, whatsoever.
It depends on the feature.
You know what? Let's make a quick vote. Who believes 2.72 is the right number to estimate? Fair number. Okay. Don't be shy. Okay. Who believes it should be more than this? Who believes it should be less than this? Okay, why do you think it should be less?
Regression to the mean.
Okay. So, what's your name?
Oran.
Oran. So, Oran is right. And this is what I want to explain here. Regression to the mean, or sometimes it is called selection bias. What are we having here? So we are testing something, we are testing two alternatives, and the test is fair, everything is okay, all the rest is equal. I get the result, the difference is 2.72, and I believe that this is the true difference between them. But if you will deploy it later, you will see that the difference is usually lower than this. Why is that happening? What did we lose here? I mean, the test is valid. Everything is equal. So what happened here? Well, what happened here, I prefer the term selection bias, and I will explain why, but nevertheless, it's the same issue. Well, when we ran the test, there were two possible results. It could be either B would win or A would win. Agree? Both is possible. And we ran the test, and eventually B won. And we make an action. We select the winning one. We didn't decide up front that we are going to select B. We said we are going to select the winning version. Okay? Not B always or A always. And this has an effect. Well, if I'll give you an example from another world, and then I go back to this example. If, let's say, you are looking at the stock exchange, and you pick the stock that made the highest lift on the last day or on the last week, and then you are going to measure it on the following day or week, will it do the same or better or worse?
You can't know. It can be better, and it can be worse.
Can't know is correct, but what on the average? It will do worse. And if I'll take the worst stock that I had and compare it to the term afterwards, it will probably do better. Okay? So
what you recommend that to?
Yeah, I'll recommend.
Worse than then?
No, I'll recommend in a minute. Okay. So what I want to say, and I will show you numbers in a minute, but I want to say that when we start the test, we had two alternatives. In some cases, A will win. In some cases, B will win. Okay? You are looking at the results that does not reflect the entire population of scenarios. It's only part of the scenarios where B won. So if A and B are competing, and you are looking at the performance of B when it won, or you're looking at the performance of B when it lost, you expect that the performance of B when it wins is better than the performance of B when it loses, right?
Not sure yet. If I compare two colors, button is two colors.
Yes.
And red.
Mm-hmm.
And the green wins.
Yes.
Maybe most of the people like the green button. And they will continue to click on the green button.
Well, let me be accurate. I'm not saying that B is not better than A.
Okay.
First, you cannot know for sure. You can be wrong. But now you need to make a choice. Would you select A or B? What I'm telling is that if you select B is probably the better choice to select. But if someone asks you, well, what is going to be your performance? And you're going to say, I'm going to perform at 11.93%, then you are going to be surprised downwards. On the average, I'm not saying always, but on the average, you should expect less than this. And if by certain reason you decided by other reasons, no matter, you decided to select A, and then you are being asked, what are performances that you expect? And you say 9.21, no, it's going to be better than this on the average. Okay? Now, I'll show you some numbers. Yeah.
I understand that it's going to be worse, but still, the why is...
Okay, I'll try to address the why. It's difficult, but I'll try to. Okay? Here are an example. Here is an example. Okay? I start with two variation A and B. And the true performance is that A converts at 10% and B at 11%. So if you know this, if you know the truth, you will say, let's take B, it is better, and 11% is what we are going to achieve. Okay? So then I'm running this test, and I'm deciding to stop at the confidence level of 5%, two-tailed significance of 5%. First type of error. Then, on the average, in 92.5% of the cases, B will win, but in 7.5% of the cases, A will win. Although it is down by 1%, he will win in 7.5% of the cases. Then I listed here the averages. When B wins, you see 11.93 versus 9.21 on the average. And when A wins, you see A has much higher margin, 13.71 compared to 7.61. That's when you stop in 5%. Okay? So I compare A to B. Let's say A was my control. I conduct the test and say, well, great results. I'm going to have 2.72% lift, increment in the conversion rate. I will talk later about lift. That's a different issue, also a problematic issue, but let's talk about this later. But in fact, all I have is 1%. I think I have 2.7, but the truth is that I have only 1. Most of the margin is virtual. It's not really there.
How do you estimate?
You don't know the truth. Truth is unknown.
You don't know the truth. And to make issues worse, I will tell you that this is the story when you have only 2 alternatives. If I test 5 alternatives, the disaster is much worse. Okay? Yeah, but the reason that you are making a selection bias the results. You are selecting the best one in the test. And that is why, in the same example that I gave you on stocks, the fact that you select the best performing stock last week means that probably you are going to get worse performance in the next week. Okay?
So we should conduct the test multiple times and average the gain?
There are first, not always you're really interested in the real number. So if you just want to make a decision, which one do I prefer, A or B, then that's okay.
Well,
Run it once. Most probably you get it right. You select the winning variation, but you're going to be surprised to the worse because you're selecting the winning variation. You're going to be surprised for the better if you're selecting the worst variation, but you're not going to do this. Because anyway, it's better to select the winning and be surprised rather than select the losing and be positively surprised. It will still not cover the gap. So first, be aware from the phenomena. There are some tricks to try to estimate the size of the phenomena. There is no clear solution for this. There is no formula or something that tells you, well, this is what you are going to expect. That is the real average margin. You don't have such a formula, but that's the issue. What you can do, you can have a different example. In this example, I decide to stop when the significance is only 1%. So I'm going to have a longer test. I'm requiring a significance level of 1%. And you can see that first, in this test, I get it wrong in 1.5% compared to 7.5% that I got it wrong in the first test. And the margin are lower now. This is closer. In this case, most of the gap is still correct. I'm losing almost half of it, but most of it is still there. In this case, most of it is lost. From 2.72, you're going to be down to 1. Okay? And what I also want to hint, and I stopped at 5%. Why did I get here 7.5% and not 5? Well, I decided to stop whenever the significance is 5%. So you are thinking that you are allowing the first error to be 5%. Why is it 7.5%? Yes, because you are checking repeatedly. Because you are not checking once, but you're continuously checking after every observation. This means that the first type of error is larger than what you expected. So it's not what you planned for. It's higher than this. It's 50% more in both cases. And also what you can see is when you get it wrong, you get it totally wrong. It's not close at all to the truth. Okay? So, question on here? Okay. Yes?
If you had stopped after a set duration.
After what?
After a set duration. Decide beforehand that 2 months
okay.
is going to be your duration. Then would then be the gain fair?
No. Well, the gain is fair. The gain is fair. What you measure is fair, yes. But the fact that you are selecting the winning one causes it to be wrong for you. The average difference between A and B is going to be 1%. That is true. But because you are selecting A when A won and B when B won, this means that you are going to lose a lot of the gain that you think you have. Okay?
If you don't choose, if you don't select,
Then you don't lose, but why do you run the test if you don't select?
No, I mean, like, if I decide to do several tests, but I decide not to decide until after several tests.
So several tests means that you lower this effect. It's similar like going from 5 to 1, but you cannot run from it. It's going to be there. Whenever you make a selection, that's you are facing an error.
If you would hypothetically run the experiment on your whole population, would it still apply?
Yeah, definitely. Yes.
Is there a formula to estimate the bias? Because
Not that I know of.
so both biases that you just described, there is no close formula or some estimate of.
Well, there is no real formula because the formula, when you see, let's say when you see these results, okay? It may result from starting from 10 and 11. It may result by starting from 9.5 and 12. It may result from multiple cases, and you don't have a prior assumption of the distribution of the prior possibilities. If you have it, then you may calculate it. But it's not simple. And that's not part of what I wanted to discuss here, because that's a huge topic on itself. Just wanted you to be aware that the results that you quote are probably wrong. Be aware. Okay?
And here you ran it 4 times, right? The test.
No, to show this, I ran it 1,000 times. I simulated it 1,000 times, and this is the average on 1,000 cases.
So from this example, what's the conclusion? Not the predicted conversion rate number, but as you said, A or B.
Definitely, you should select the winning one. Okay? If you say asking who is going to perform better, the winning one has a higher probability to perform better, or the average.
Sometimes B won and sometimes A won.
Yeah, but I can tell you which one is wrong here because I know what I started with. You don't know the truth when you run a test. That's the entire issue. You don't know. So your best call is to select the winning one, but be aware that what you estimate is not accurate. Well, when we give estimates, the estimates are not accurate ever. We have a margin of error. What I want to say is that you have a bias. It's not a margin of error. A typical statistician will tell you, well, the difference here is 2.72 plus minus, let's say, 2%. Well, the fact is it's minus, not plus minus. It's minus, and somewhere around minus a lot, you have the result. Okay?
It's minus as a predictor of what will happen in the future after you make a selection,
yes.
but not as an estimate of what happened to the whole population in the past. Right? So, I mean, well,
the purpose of the test is not to estimate what happened. It's to make a decision for the future. Because when I ran the test, I had the results. You cannot change the result. You have the number of conversions that you have. Now you need to make a call. Are you going to select A or B? Well, yes, you need to select the winning one, but be aware that it's not going to perform on the level that you expect it to. And as I said, if you are going to have, let's say, 10 variation and you want to select the winning one of the 10, then the margin that you will see in the test, most of it, at least 90% of this margin is going to be lost usually. I mean, sometimes when there is a huge difference, if A and B were not 10 and 11, if A was 10 and B was 30, then this effect would not happen because always B would win. Then there would be any bias. See, if you had here 100%, then there is no bias because this is the entire cases. The issue is that when you run A versus B, A can win or B can win. You look only at the cases where B won. You are losing this part of the population, which is on the other side, and that is why this one is too positive. If there is a clear margin between them, then there's not going to be an issue. Okay? Okay, so that's what I talked about. So I talked about it, so I don't want to cover it. So here are some observations that I talked about, some of them. Independence between objects in the sample. Usually you lose it. You don't have real independence because traffic is changing during the test and you may have the same visitor twice. If you want to have fairness, you need to have a clear random that is working correctly. Not a big issue, but you need to have it. And the significance level that when you set it, let's say, as I show you, for 5%, it's not really a 5% if you are continuously evaluating the results. Now, someone here asked, well, what about if I'm not doing it continuously? If I'm evaluating once, let's say after 2 months, well, then you will not have this factor. If you set it to 5, you will have 5. But what if I ran the test for 2 months and I don't have significant results? So I can stop and say no result, or I can say let's continue, and this brings back this issue. So usually you will have a higher error rate than you expect. Okay, how do you have a traffic split? You want to have a traffic split 70-30 or 50-50. How do you handle it? Some cases there are structure of round robin, which means I'm going to allocate one by one by, let's say, justice, which one the variation that got less than what expected will get the next one. Well, this gives you the percentage that you want, but that's not independent. It means that every visitor depends on the previous visitor. So you lose this independency. I'm not saying that's a huge mistake, but
what do you gain? What is this?
Let's say you have 30-70, the split that you want. So round robin means that when I have a new visitor, I look at the previous allocation that I have. If A, that is designated to have 30%, have less than 30%, I will allocate it to A. If it has more than 30%, this means that B has less than 70, I will allocate it to B.
But under large numbers, will not matter.
I'm talking just about round robin. That's the system of round robin. It's even the split accurately, but it means that the selection is not independent. And can we change the split? I mean, I'm starting with 70-30, and I want to change to 50-50. Is this okay? Is this valid? Who thinks yes? Who thinks no? Okay. Well, the answer is no. Why? Why is this not valid? Because this violates the fairness of the test. Remember, we said that the probability of every individual in the population must be the same to be allocated to either A or B. If you change it, it means that for certain individual it was 30-70, for either it was 50-50. It violates this assumption, and it means that if the traffic changes during the test, you are going to see results that are not accurate. Okay, can be misleading. So try to avoid this. Okay. What happened here? Oh, yes. Now, let's look at a bit different example. I still want to test A and B, but I'm testing it not only in one scenario. I have several scenarios. You can think of it as different sites or different objectives that I want to achieve. Let's say in one of them I want to achieve conversion, in one of them I want to achieve registration, in one of them I want to achieve something else. And I want to test them. I don't want to combine all of them together because they are different populations. The visitors that I'm targeting for registration are different from those that are targeting for conversion, etc. So I cannot combine all of them together. This will violate the independency. So I'm going to run 3 different tests for each group differently. But I want to make a same conclusion, whether A or B. Okay? Everyone understand the setting? So how can I evaluate? I have 3 different populations. Each of them I compare A to B, have the results of A versus B, and I want to make one decision whether I'm going to go with A or with B. So we have a simple setting. I'm not saying that this is the optimal, but a simple setting. I cannot sum conversions with, let's say, dollar value. I don't know how to sum them together. So what I'm going to do is I'm going to measure the lift of A versus B in the first one, the lift of A versus B in the second one, the lift of A versus B in the third one. Let's assume that all of them are with the same importance for the simplicity.
Just to be on the same page, A versus B, the first one you mean conversion, and then A versus B?
Registration.
Registration,
okay.
Or revenue, or
yes. Yes. So I'm going to compare the lift of A over B in the first one, A over B in the second one, A over B in the third one, sum them all, calculate the average, because as I said, they are all in the same importance, and then I'm going to conclude which one is better.
What's the lift?
What?
What is the lift?
Lift is the relative difference. Okay? So how should I do it? Should I calculate A over B or B over A? What is the right way to calculate? Does it matter?
Depends what's your default setup.
My default is A.
Why
It should be the age.
Just telling. That's the story I'm telling. Okay.
So B, the account.
So we want to measure B over A.
B over.
Depends on the winner.
You don't know who is the winner. We are starting the test. Who thinks this is the right call? Making B over the challenging over the default.
I think you should test all the alternatives.
When you say all, either you say it's not important, or if I get different results, you should tell me what do I need to do.
I think you should get A over B for each experiment, review metrics,
Yes?
and then select which one are the best options.
Okay, so you're saying A over B in all. Okay. So who thinks I should do A over B, control over the challenging and not challenging over control? Nobody. Who thinks I need to do something else? That both are incorrect. What?
Don't you have conversion rate before the test began?
The conversion rate before is irrelevant. You have the control variation, so you compare side by side. That's the most accurate way to compare it. Yes?
Wouldn't you want to pick the winner per location?
No, you must pick the same one for all three. You can have, in this example,
Why not just calculate one metric for A and one for B and pick the best one?
what do you mean one metric?
I do all the mixing of the different metrics for A separately and for B separately, come up with one metric for each, and just...
But I don't know how to do it. How do you combine conversion rate with revenue?
How do you combine it this way? It's the same.
I said I compare. I compare.
Oranges with apples.
I'm comparing in the conversion rate. I say what is the lift, the ratio of A over B in the first setting? What is the ratio of A over B in the second setting? I merge them together, I do the average, and if the average is over 1, I conclude that A is better than B. If the average is below 1, I conclude that B is better than A.
But effectively, if you compute the lift, you've basically normalized all three, registrations into kind of the same scales.
Yeah, I'm saying that let's assume that this is the case. I'm saying all of them are in equal importance.
So you can merge them with equal importance separately for A, separately for B.
How?
Average, just like you do on the
What's the average of $6 plus 7% conversion? What's the average between them?
Okay, so you need to normalize them.
Okay.
But still, you do it separately. You can still.
If you can do it separately, fine. But that's not the case here. Okay. So the correct answer is that both is wrong. A over B and B over A both are wrong. Why is that? You want to explain?
Is there a chance of eating Simpson's paradox here?
That's not because of the Simpson paradox. The Simpson paradox is an example that I have a slide about Simpson paradox here, but it's an example talking about when you compare two alternatives and each alternative is better, and you have two types of populations, and one alternative is better in both population, in each of the population, but if you make the combine of two populations together, you get the reverse results. So I will talk about this, but let's continue here. Here I gave you an example. In the first row, A did 8%, B did 10%, so the lift of B over A is 25%. In the second, A did 10, B did 8, the lift is minus 20. So you conclude, if you say do B over A, you say B is better. If you do A over B, you conclude A is better. What's happening here? How can it be?
That's all wrong. You should have compared the two row data and then do the uplift of or lift of one over the other.
What do you mean two row data?
I mean, you don't need to. You should not look at the lift of each of them and then compare the lifts. That's like
This is the way that I'm normalizing it. I'm saying in the first row, B did 20%, 25% better than A. In the second one, B did minus 20% compared to A. So it looks like B is better. Not really. Agree?
because the starting line.
There's no answer.
Okay. So what's going on here? Let me explain. Well, the issue is that when you calculate lift, you do B over A, for example, you give B an advantage. Why is that? Because when B wins, A is lower, right? So you divide by the lower number. And when A wins, A is the higher. So you divide by the higher number. Okay? This is what's happening here.
Take the higher and divide by the lower one.
Okay, you can do higher divided by the lower or divide the margin by the average of the two, but not straight lift. Straight lift is wrong. Is a wrong metric.
What about using a geometric mean instead of, that wouldn't yield?
Well, geometric mean of what?
You compute the lifts. I mean, part of the problem is that you're computing lifts and you're summing them, right? So
But here, if I do geometric mean here, I will say that the result will be positive for B. And here it will be positive for A. It doesn't help you. Okay, so solution, we can discuss it offline, but be aware that lift is a misleading measure. Whenever you make a lift and you say, I'm going to make a lift over A, it means that you are violating the test and you are measuring the results in a way that B is looking better than it is. And if you're doing it over B, then the opposite occurs. So it's not best practice to do either one of them. Okay. Oh, I think okay. This is the Simpson paradox. Okay, what is the example here? I have two types of visitors. New visitors, first time to my website, and returning visitor. They were visited already before, and this is not the first visit. And for this example, I am telling you that variation A is doing 6% conversion rate on the new ones and 15% on the returning ones. Variation B is doing 5% on the new and 40% on the returning. Okay? So definitely A is better than B. Okay? In both populations, it is better. Okay? So here's the continuation of the story. I'm looking at my traffic to weekdays traffic and weekend traffic. On weekday traffic, most of the visitors are new. In weekend traffic, most of the visitors are returning. That's just for the sake of the example. When I start the test on weekday, I'm allocating 90% of the traffic to A and 10% to B. And then on the weekend, I'm doing 50-50. And you can see that the results are showing that B is doing better than A significantly, 20% more. Although it is worse in both populations. Okay, you can follow the math. Well, it's accurate, believe me. It's not that complex, but that's the Simpson paradox. That is because I changed the traffic split. I started, you see, on the weekday, I have more of new. And remember here in the example, the returning are the better visitors. So this is, the weekend traffic is better than the weekday traffic. And variation A is having more bad traffic than the good traffic compared to variation B, that's having more good traffic over the bad traffic. That is why the total results are opposite to what you expect.
You explain that why not to do a 50-50 split?
No, I'm saying that you cannot change the split. I'm not saying don't do 50-50.
Why do 70-30?
Okay, I didn't address this yet. Let's do it now. Why should you do something that is not 50-50? Well, sometimes due to business reasons, you don't want to risk too much, a lot of the traffic, and you want to allocate a small size of the traffic to the challenging variation. This can happen. But let's say this is not the case. You can do whatever you want. So the optimal setting is not definitely 50-50, but the optimal setting is the one that balances the ratio according to the variance. You want to allocate more traffic to the variation where the variance is higher. Because you want to reduce the variance, this affects the accuracy of the test. That's in a high level. Let's now focus on most scenarios. You can assume that the variance is the same for A and B, and therefore the best way to conduct the test in terms of having it fast and most accurate is 50-50. But it's not always the case. I can construct examples that it's not 50-50. That's not difficult to construct example. But if you are asking about best practice in practical life, 50-50 is most probably your best way to do. Yeah?
How do you calculate the total conversion factor?
The what?
The total conversion rate. How do you calculate?
Okay. What you see is the following. You have variation A has 90% of the traffic here. What is the conversion rate of the traffic here? Is 80% of 6 and 20% of 15 is the weighted average between the two. You get the number, same you do here, and then you weight between them according to the traffic, and you calculate it. I mean, I can show you the calculation. It's not that difficult. But in the Simpson paradox, they're showing it on a medical treatment. I think the standard example is talking about a procedure about stones in the kidney, when you have large stones and small stones, and one procedure is dominating in both examples, but because the mix is different, then it looks like the other approach is better. So that's the Simpson paradox, and that is why we don't want to change the split. Any questions here? Okay. I think. Yeah.
So we were doing an A/B test a while ago, and what we were doing was that we had 3 groups: one control, one the test, and the third one was just production. So basically, the A experience, we split it unevenly between something that was control and something that we just didn't put into the measurements, and so the population that we compared A versus B was 50-50, and the rest we just was like a garbage can.
Okay.
Is this valid?
Yes, definitely. What you are saying is that you took aside certain percentage of the population, you call it production, and you don't use it for the test. That's okay. It doesn't violate any assumption that we have on the A/B test.
I mean, it was good because then you don't compromise, the overall experience of
Okay.
the majority of the users.
The test is
Yes.
has more errors.
Yeah, you need a longer period of test, or the test has more error, but it's a fair test.
Yeah, we had enough time, so
Okay. Okay. Well, here I just want to show you a simple example. I want to start with 3 variations, A, B, and C. And then after a while, I want to eliminate the yellow one, the B one. So, and I want to continue with A and B. With A and C, excuse me. This is A, this is C, this is B. I had B at the start. I want to now use only 2. And I don't want to lose, I mean, what are my options? If I look at the results here and compare A and C, I may see something, but usually it's not enough. I don't have significant difference. So I'm starting here 50-50, and I can disregard this period and start from scratch. This is an alternative. But I would like to combine both periods and use this green compared to this red. Is this a valid setting?
Yeah.
What? Does this violate something?
Can I ask a question regarding the setting?
Yes.
Your decision to drop the middle variation?
No, doesn't matter why.
No, but okay, but because your A/B test, you can only, like the theory only compares 2 at a time. So you have 3.
No, I can compare multiple. That's A/B test is not just for 2. As I said, I gave the example on 2, but you can do it for multiple. That's fair. You can run 4 variations at the same time, 10 variations whatsoever. I'll give you just a simple example. I have 3 salesmen that I'm going to test. I'm going to allocate my leads to the 3 of them. After a while, salesman B quit, is no longer there. Should I restart the test, or can I continue A versus C?
Violate fairness if you do.
Why?
Because you say that those people split.
I split his population evenly. So what did I violate?
So they may be biased due to his treatment.
Due to what?
If they happen to love his sales, whatever, sales skills, and the red one is more like him, so they are going to convert more.
Okay, now let's assume for the moment that every point here is new one. I mean, those that were here were not exposed to him. Okay? They didn't talk with salesman B. Is this a valid setting? Can I keep it, or should I restart?
If they are independent.
Yeah, they are independent. Well, does this violate the fairness? If I'm looking at someone that is in... First, let's define carefully what is the population of this test. The population of this test are all non-yellow participants here. Okay, this is the population of the test. It's not the entire population, but only this. Well, you may think that it looks like we changed the traffic, what I said we cannot do. Is this the case? If you look at a certain visitor in the population, someone that is not in the yellow, what is the probability that if I'm selecting randomly one that is not in the yellow, what is the probability of this person to be red? 50%. Probability to be...
She did when she threw away some of the...
Yeah, but here we throw away and we evenly split between them, and this is why it is fair. In the general case, let's say these were not 50-50. Let's say I did 20% here and 40% here, and this one has also 40%. Okay? Again, this 20, 40, 40. What do I need to do now? You need to split them. The ratio between these two with this is 1 to 2, 20 to 40. So I need to keep this ratio to be fair. So I need to split them in rate of 1 to 2 to keep the fairness. Otherwise, violating the fairness of the test. Okay? So it's possible to remove alternatives and continue the test, but you need to do it carefully. Okay. Can I run multiple A/B tests simultaneously? So I had, as I said, 2 variation here, 2 layout of a certain page. Let's say I want to test another page with 3 variation, and I have another page when I want to test 2 variations. Can I run all tests simultaneously?
No, because you violate equality between different.
You say I'm violating the what?
Other things being equal.
That all the rest are being equal? Let me draw this, okay? I have here 1 page, 1 page, 1 page. I split here A and B. I split here C versus D. And here I have E versus F versus G. When a visitor arrives to this page, I'm selecting randomly A or B. When he arrives to this page, I'm selecting randomly C or D. And here I'm selecting E or F or G. Is this okay? Can I run all tests together at the same time? Same site.
So no.
They're independent pages.
But if
Well, remember the terms. Fairness, independency, all the rest being equal. If you look on a visitor that was exposed here to A compared to one that was exposed here to B, do I have fairness? I mean, are they fairly split? Yes. All the rest being equal?
yes, right now, yes. The next one.
What is different? This one that was A here can get here C or D. The one that got B here can get here C or D. They're the same distribution. So what is different?
It's not independent. If it went to A, B, and then went to C, D, it's not independent.
Why it's not independent? Okay.
If you gave him an A and B,
I have.
it was green button and red button.
Okay. I have 3. I'll give you the scenario. I have 2 different coins. I draw one of them to decide A or B. I draw another one to decide C or D. I make the decision before the session starts.
In some cases, you might get the wrong result in C and D because people that came from B chose D and...
No, you cannot choose. I'm choosing for you.
Yeah, you choose for me, but the result of the test will be affected by the previous...
How?
They have a perception from the previous page.
Yeah, but on average,
Okay, let's say this page affects this page, okay? I'm going with you. Let's say what you see here affects what you are doing here. But those who see here D had 50% of them saw A, 50% saw B. Those who saw C, 50% of them saw A, 50% saw B. So they saw the same.
That's not necessarily true, because what happens if people who see A
Mm-hmm.
are drawn because of it to see one of C or D?
Yeah, but people who see here say, 50% of them see C and 50% see D.
Yeah, but consider people who see A will convert better on C, and people who see B will convert better on D. But less people who see B reach that choice, right? So that's
Okay, so you are talking about, that there is what is called interaction. The term that is using here, that the effect of A is different whether it's C on D or D. And B has different effect whether it's C on D. This is called interaction. Well, interaction is a good story. Usually it doesn't really exist, but it's a good story. Let's assume that there is no interaction. Is this a fair setting?
Yes.
Yes. Well, in fact, when you are running an A/B test, there are multiple tests that are running that you are not aware of. The marketing people are running tests about the campaigns that they are going to buy. Some production people might running tests about the technology they are using. You are not aware of all these tests. Yeah. The recommendation system that you use may run a test on the algorithm that they are using. You are not aware of this. So that's the nature of life. People are running tests all the time. As long as the tests are independent, that's perfectly okay. You can run all of them at the same time. You can conclude one and continue the others. That's fair. Just keep them independent. Okay? And they can be on the same page. While they are still independent, that's okay. It doesn't need to be on different pages. Okay, I think that's...
Do you have a way of telling if they were independent? Did you look at the result? You're not sure.
No. Oh, you can measure how many times you had A and C, how many times you had A and D, etc. And if you make a chi-square comparison of the matrix, you can see whether they are independent. You can test it. Well, these were the topics that I wanted to cover. I think that I use all the time. Any questions?
If you have the same page, so do the same interactions still don't exist? It seems to me that if you have the same page with multiple buttons, it's a bad test.
No, it's not. Well, the issue are the interaction between the content. If there is an interaction, and this, in fact, you can test whether there is an interaction. There is a test to conduct it, whether there are independency or there is an interaction. Again, it's a chi-square test with a different setting, but you can test it. Usually, you will not see interaction in most cases. If there is an interaction, you can. It's not a fair setting, but usually it's okay. Yes?
Be an interaction between the splits, not between the...
No, between the content. If A, let's say here...
the content is the whole circle.
No, I'm saying, let's say here in this layout, C use a red layout and D is using a blue layout. Okay, red and blue. Here A is red, but this one is yellow. So red looks better with red, but yellow has nothing to do with the other two. So this may affect the results, for example. But usually, this is not the case.
But it would still be fair in terms of the conclusion that you draw from it. You can't say that if you chose, if A and C, for example, won,
yeah,
and you chose A and C, then the combined lift won't necessarily be...
Yeah, but I will explain what is the issue. When I started, I said you have two alternatives. Let's say you have a blue layout, you said, compared to white layout. Okay? Now let's say that someone in your website is running another test about the color of the font, and you want to test white against red. So those that will get the white layout, if they will allocate to the white font, they will see nothing. And this will affect the results because of the interaction between the content, not because of the settings. You cannot control the settings, but that's something that if you are aware of, try to avoid. But
Still, if the
Okay?
Independent, it won't affect the result of the...
No, it will, because those that, here,
Exactly what you said.
they are independent. Here, you have this is the font, and this is the color, the background. Okay?
Background doesn't interest me, I only test the...
You have white and red, let's say, or white and black. And here you test white versus blue. Someone else is testing white versus blue. So you will conduct, if you will conduct a test and you are not aware of this test, you will conclude that black is better than white. That is only because some of your visitors had white background, and when they have a white font, they saw nothing.
But if you are aware that you have just 4 different groups that you can compare.
If you are aware that you have this, it doesn't make sense to test this.
Right.
Okay? Makes no sense. Okay? If you are not aware, then you're doing the best that you can. But if this happens, then you are violating, you're misleading by the conclusion. Yes?
In a company, we have different teams doing A/B testing in different ways.
Mm-hmm.
One of the differences is the way of recruitment. One team is working with limited recruitment, so they get to 100,000 for each group. And
Okay.
stop. And a different team is doing a continuous recruitment.
Okay.
Is one better than the other?
What are you testing? What do you want to measure?
Let's say we're measuring revenue per user.
Well, that's not a. You have different number of visitors in both settings. You say one of them recruits faster, so it has more visitors than the other. It's not a. Who are the population here?
It's 2 different products, yeah. Let's say one product they recruit 150,000 for 2 groups.
Mm-hmm.
Each group claim 150,000. Let's say they do the recruitment within 2 days.
Okay.
And another one is another product is doing A/B testing with continuous recruitment. So they,
Each one of them is okay.
phase, but they just keep going.
Yeah. So you don't want to test the first versus the second. Each one of them, it's okay.
You just notice that there's different ways of recruitment, and I wonder if one way is better than the other.
So you want to test the recruitment process, which one is better?
I'm not testing. I'm asking you from experience.
That's not a standard test. It does not really fall within the guidelines of the A/B test, but we can discuss this offline. Okay, thank you very much.